Yes. Okay. Yeah, morning all. So Azure Databricks with PySpark. Myself, I'm Vijay. So before I start, can anyone please confirm whether my voice is clear, whether the screen is visible or not? Yes. Yeah.
Yeah, you're good. And
Fine.
so,
So Azure Databricks with PySpark. So what is a Databricks? So here, what is Databricks? So generally, Databricks. I'll come back to Azure Databricks, but what do you mean by general Databricks? Databricks provides a Spark cluster. Databricks provides Spark cluster. You may ask, what is Spark and what is cluster? What is Spark? What is a cluster? So yes, so before I go, right, before I go with this, just have a look about this. What is that course structure, what we are going to discuss, right? So I'll come back to this. Just have a look. Azure Databricks with PySpark, just some knowledge on this big data, Hadoop, knowledge on the Spark, cloud computing. Here we are on the Azure cloud. So introduction to Azure Databricks, creating Azure Databricks service using Azure's command line interface, Azure Resource Manager, and adding users and groups to the workspace, creating cluster from the UI, and creating notebooks, right? Yes. Databricks cluster management, creating, managing clusters, displaying cluster, starting a cluster, terminating a cluster, deleting a cluster, cluster information, cluster logs, cluster access control, types of clusters, all-purpose cluster, job cluster, Databricks pools, without pools, with pools, and auto scaling, Databricks utilities, credential utility, data utility, file system utility, job utility, library utility, secrets, widgets, limitations, Databricks integration with different storages, right? Like blob storage, Azure Data Lake, Azure SQL database like Synapse and Snowflake. Then coming to this, mainly in this Databricks, the main execution engine is Spark, that is PySpark. We say Spark with Python implementation, PySpark, SQL data frames, data frame API. So creating data frames. Uh, d- so all these things, right? Struct type, struct field, different API functions of this PySpark. PySpark SQL functions, aggregate functions, window functions, JSON functions, data and timestamp functions, reading and writing with different file formats. PySpark various built-in functions with many working examples. People might be knowing about data factory, right? People, if you already got knowledge on this data factory, Azure data factory, right? Data factory is a kind of ETL, cloud-based ETL, just like Informatica you got, right? Just like Informatica, it is a on-premise one. Informatica is on-premise, but on cloud we have got Azure ADF, Azure Data Factory. In the data factory, everything will be drag and drop. We have got inbuilt transformations where you will perform drag and drop. But here in PySpark, all our functions, we have got many functions. Here with the simple functions, you can perform it. It is code based only. Some basic Python knowledge required for this. So the various built-in functions with many working examples to perform the different data engineering operations. Databricks handling a different file, working with different file formats here. CSV, JSON, Parquet, Excel, XML, ORC, Avro files. Databricks batch processing. Batch historical data load, incremental data load, date transformations, aggregations, joins, window functions, union, and PySpark external sources working with different statements and also integration with different other things, narrow and wide transformations, window functions, creating tables from these data frames, internal, external, temporal tables. Databricks streaming API. What is streaming? Process of streaming, handling bad records, loading the data. And the Databricks Lakehouse, Delta Lake. Difference between Data Lake and Delta Lake. Features of Delta Lake. How to create a Delta Lake? Yes. Made statements, handling SCD type 1, SCD type 2, data duplications, workflows in Databricks. Introduction to the workflows, creating, running, managing Databricks jobs, scheduling Databricks jobs, and monitoring Databricks jobs. So this 20 topics, right? These 20 topics we'll be discussing in brief in this Azure Databricks PySpark.
Sir, Azure Databricks is mandatory for PySpark.
See, try to understand. Just I'll brief you, right? Um,
Actually, I'm start level, so what I understand from PySpark is it is combination of the Python and Spark.
one second, one second. I'll brief you, right? What is Spark and what is Databricks and
Oh.
what is Azure Databricks? So, okay.
So instead Azure can be used GCP.
See, any data engineering course with cloud is fine. With Azure, now Databricks is not only for Azure, it is also there for GCP also.
Okay.
For AWS also it is got, right? Databricks is not only for Azure, it is for all the cloud, right? For Azure cloud, for Google cloud, or for this AWS. For all it is available, Databricks. Mainly Databricks provides what? Spark cluster. Provides Spark cluster. I'll come back to this, what is Spark, but what is a cluster? Generally. So I want the sessions to be interactive, right? Everyone, just whatever you have got knowledge, you can just interact with me. I want the sessions to be more interactive. So anyone, what is a cluster?
It's a
What? Yes,
group of systems which are interconnected.
yes, yes. So
Group.
here, uh, in a simple way, right? Group of nodes, nothing but systems connected in a network. Okay. Generally, there are two types of nodes. Nodes means systems connected in a network. There are two types of nodes. Two types of nodes. We say like driver node, worker node. Driver node, worker node. So Databricks, why Azure Databricks? There are two types of nodes, driver node and worker node. For example, if we have 20 node cluster, if we have got 20 node cluster, in that one will be the driver and all the remaining will be the worker nodes. One will be the driver and all the remaining will be the worker nodes. So generally, in the case of Spark, see, Spark is a very high speed processing execution model. Spark is a very high speed processing execution model which process huge data at a very quick time, right? So in the case of Spark, you may ask, it's a in-memory computate, in-memory in-memory computing In-memory computing means data stored within the memory, data processed within the memory. Data stored in the memory and data processed within. Generally, data will be stored in the disk, but here in the case of Spark, totally data in the RAM level computation, data storing in the RAM, data processing with the RAM within the RAM. That's why very high speed you are going to see as compared with other technologies, right? I'll say the speed of Spark. And here one more thing in Spark, you see MPP. MPP means massive parallel processing. Massive parallel processing. Massive parallel processing, right? See, massive parallel processing means generally a labor example. I'll say I'll give a labor example. A building construction, that is a job. If you are giving, how many labors required? The more the number of labors, the more the speed. Here, Spark is for very high speed processing execution model. If you want a high speed, right? So here, how the processing happens? If I take a labor example, a building construction, more number of labors. If the job is divided into multiple tasks, the multiple tasks given to multiple labors, they'll be working parallelly, running parallelly, right? So the work will be completed faster. In the same way, if you got a data, Spark is for huge data processing, like TBs or petabytes of data. Spark data object will be divided into smaller parts, we say like partitions. That partitions are distributed across multiple RAMs of multiple worker nodes. For example, if you've got some 50 node cluster, 50 systems, data will be distributed across 50 RAMs of 50 worker nodes and they'll be running parallelly, working on a single job. See, Spark data divided into partitions, distributed across multiple RAMs of multiple worker nodes and processed parallelly. That's why because of this massive parallel processing, you see very high speed. Multiple systems, multiple nodes running parallelly, working on a single job. That's why very high speed. So here data will be distributed. So here data is, see, whenever this big data Hadoop, Big Data Hadoop brought a revolution in distributed computation. Distributed computation, right? Previously, monolithic computation, right? Only a single system was processing, but whenever Big Data Hadoop, it brought a revolution on distributed computation where the data is distributed across multiple systems, processed by multiple systems parallelly. So data will be distributed across multiple worker nodes and is executed. Multiple worker nodes parallelly. Data will be distributed across multiple worker nodes and is executed by multiple worker nodes parallelly. Spark, if I talk Spark is 100 times faster. It is 100 times faster. Normal disk processing. Normal disk processing. It is 100 times faster than normal disk processing. For example, so Databricks provides a Spark cluster. Who provides a Spark cluster? Databricks provides a Spark cluster. Assume assume a cluster with 100 nodes. 100 systems. This 100 nodes cluster, this 100 nodes cluster is worthy processing 1 TB of data. 1 TB of data at a time. This 100 nodes cluster is worthy processing 1 TB of data at a time. For example, tomorrow your data volume increased. At a time, it is going to process 1 TB of data at a time. 100. Tomorrow your data volume increased. Hmm. Increased by huge amount. If same cluster used, if same cluster is used, hmm, speed goes down. Speed goes down, right? Generally, simple labor example. Yes, you are carrying a bag of 10 kgs. You can run with that bag, but if that weight of that bag is increased to 20 kgs, the speed will decrease. In the same way, if volume increased, the speed goes down. So here, 100 nodes cluster can process 1 TB data. If the same cluster is used, speed goes down if the volume increased. To achieve what? To achieve high speed. To achieve high speed, what is the solution? To achieve high speed, what is the solution?
Increase more nodes.
Increase worker node.
See, uh, for example, two horses, two horses, they're carrying some load, some 50 kg load. They can go with some speed. But if the load is increased to 100 kgs, the speed of the horses decreases. To achieve the speed, what I should do? I should increase the number of horses from 2 to 10 so that the more speed you will be getting. And still, if I increase more number of horses, they can increase the speed, they can run faster. So as the load is increasing, as the data load is increasing, the here also the same thing. To achieve high speed, solution.
Sir, what is the optimum size of data one node can process, like without failing or without like getting slowed?
What is it? What is the
So, what is the
see
size of
see
data a
the
particular node can process?
see what is see depends upon the organization. See, for example, here in the case of Spark, memory is important. For example, 64 GB memory, assume 64. I'm not talking about the disk. Here in Spark, Spark is an in-memory computation system, so memory is important here. 64 GB memory, 100 systems. Total memory available is total memory
400
6400.
GB.
6400 GB it can maintain. Means it can accommodate this much of, if any is to Spark data object, if the size is, it can accommodate. So if you're bigger that object, data object size, you need to maintain that much memory, you need to maintain it. If you want to high speed, that much of memory has to be maintained. So totally, uh, either you need to maintain huge RAMs, you need to maintain huge RAMs because of this in-memory computation only. That's why it is 100 times faster, 100 times faster than normal disk processing. So here mainly data will sit in the RAMs. How the Spark processing is going to happen, I'll be discussing, right? But here, what is Databricks? What is Azure Databricks? For that, try to understand this solution to achieve high speed, right? Scaling up the cluster. Scaling up the cluster is nothing but scaling means what? Adding new nodes. Scaling up the cluster by adding 50 new nodes. 50 new nodes is nothing but new systems. If you're running a business, if you are running a very small business with 10 nodes, with 10 systems, your business has increased, your customers have increased, your branches have increased, your data has increased, then your number of nodes also has to increase, right? Same way here, scaling up the cluster by, so if data increased by 100 times, customer increased by 1000 times, right? Your data also to be increased, right? Yes. Means your number of systems, the cluster capacity also should be increased. So you're adding 50 new nodes. After 1 month, assume after 1 month, again data increased, and again 50 nodes, 50 new nodes added. Every time, whenever the data is increasing, every time scaling up your physical data center is a complex task. Understand here. Every time scaling up your physical data center is a complex task. So what is the solution? So the solution, same cluster, I want in the cloud, same cluster in the cloud. Previously, if you observe, everything done in the on-premises, if everything done manually, where you used to arrange some systems which are interconnected and installing all the softwares, installing all this Spark in each and every systems, everything, maintaining all this. But here, same cluster in the cloud, same cluster in the cloud, and that too, and that too, with auto scaling feature. Who is providing this? Who is providing this? Databricks. Understood. Databricks. Who is providing this? Databricks. So Databricks is providing a Spark cluster with auto scaling features. Spark Cloud cluster. Spark Cloud cluster with auto scaling feature. Today, my organization data load. For example, today my organization data load requires 100 nodes. It requires 100 nodes. For example, tomorrow data volume increased. Hmm. It has to be extended. 200 automatically, right? That is what auto scaling feature means. What if data volume increased, your number of nodes also has to be increased automatically. And again after processing, or again after processing is completed, it has to revert back, to 100 nodes. Initially it requires 100 nodes only, to 100 nodes, but when data volume increase, it has to be extended to 200. Again after processing complete, it has to revert back to 100 nodes. This is general Databricks. See, general Databricks is not compatible. All the Azure storages. All the Azure storages. What are the Azure storage services? Azure storage services are what?
Azure Blob.
Azure Data Lake Storage, Azure Blob Storage.
Azure Data Lake we are using mostly today. Azure Data Lake. Still
Azure Blob. Azure Blob.
Azure SQL you can say.
So there is one question here in like data volume increase line. So for example, I am paying for 50 nodes for 100 nodes. If data volume increase, it automatically goes to 200 nodes. And if the processing is ETL is completed, it will again come back to 100 nodes. So like I didn't get this line. Like
See, generally, you will be charged if the number of nodes are increased, you will be charged for that. So how many nodes you will be, see, in the case of data bricks, see, in the case of Azure Data Factory, the cluster, you cannot control the cluster. Default cluster will be running in Azure Data Factory. In Azure Data Bricks, you are supposed to create the cluster. How many systems you want? How many nodes required? You need to give the number. Single node cluster, multi-node cluster. Multi-node cluster, how many required? 5 required, 10 required, 20 required, 50 required, 100 required. For example, 5 to 10 if we say. 5 is the min, 10 is the max. Means it will take the min if with 5 systems if you are able to do that work, okay. Otherwise it will scale up to 10 you are saying. You are giving the scaling 5 to 10. Here also 100 to 200 I'll give the scaling. 100 to 200, min value 100, max 200. So it will go with this. But whenever data volume increase, it will automatically scale up to 200.
yeah.
You will be giving that range there up to which node to 100 to 200 nodes. But whenever data volume increase, it can scale up to 200. Generally, in your practice, right, you'll be if you are using multi-node cluster, for example, 3 nodes to 8 nodes if you give. So whenever required, it will go with if huge data. Azure Storage Service, see, generally, general Databricks is not compatible with all the Azure storages like Azure Data Lake, Azure SQL, even like for NoSQL kind of things, Azure Cosmos DB. So all this, etc. Regular Databricks, right, is not compatible with this storages. That's why Microsoft plus Microsoft and Databricks. Microsoft and Databricks collaboratively, they launched a new product called as Azure Databricks. Azure Databricks, ADB. So what is this Azure Databricks? ADB, right? It is a Spark. It is a Spark cluster with auto scaling, and compatible. All the Azure data storage services. It is compatible with all the Azure storage services. For normal Databricks also it is possible, but we need to do a lot of other settings. We need to do a lot of other settings. We need to call different APIs. We need to call different APIs. So here, Databricks is not only for Azure. Okay. In Databricks, try to understand here in Databricks, who is processing the data? Who is processing the data?
Cluster.
Spark.
Spark.
Spark is the main execution. So Spark for that Spark we require a cluster. So what is Azure Databricks finally? So what is Azure Databricks? Is a Spark based. It's totally a Spark based data analytics, Spark based data analytics platform. Okay. So Databricks is Spark based data analytics platform. So Apache Spark. Apache Spark, we say it is Apache product is an I can define Spark in 5 lines. If I define Spark, it is an open source distributed cluster computing framework. Cluster computing framework with in-memory computation feature with in-memory computing feature in parallel process style. In parallel process style used for large scale data processing. So it is an open source distributed cluster computing framework with in-memory computing feature in parallel process style used for large scale data processing. So here,
Why other database technologies not using Spark? Is there any
why
particular reason?
why
Other
other?
database technologies like Teradata or Snowflake or
Okay,
Couchbase not using Spark?
okay, 1 second. So Yahoo has conducted a test to check the speed of different things. Yahoo has taken a table of 100 TB. Has taken a table of 100 TB consisting of 1024 columns. Mm. Task sorting based on 16 columns. Sorting based on 16 columns. So what is the time taken? So to sort these 16 columns, so of this 100 TB data with 1024 columns, time taken by different databases, as you said, different databases, right? We got the normal databases, we have got specialized databases used for data warehouse purpose. If we talk Oracle, we have got Oracle, MySQL, we got like Teradata. Teradata is a specialized database used for data warehouse, right? And even not only Teradata, we have got Netija, Vertica. Ooh. So Oracle, it has taken around 3.5 days to process. MySQL, it has taken around 6 days to process. Teradata, specialized database used for data warehouse, it has just taken 4.5 hours. Netija, it has taken just 3 hours time. Big data Hadoop, It has just taken 3.4 minutes. Understand here? Hadoop has just taken 3.4 minutes. Hadoop is also a what? Distributed cluster computing framework, parallel process style, open source used for large scale data processing. Hadoop, I said let Hadoop, it brought a revolution in distributed computing where data is distributed along multiple systems running parallelly, parallel processing. The difference between Hadoop and Spark, when Spark into the market, then Hadoop got, means Hadoop is got little outdated. So there is no in-memory computation. So here in Hadoop, we got a map-reduce execution. In Hadoop, we got a map-reduce execution model. In Spark, is 100 times faster. Is 100 times faster than Hadoop. MR is nothing but map-reduce. That map-reduce execution model. Map-reduce execution model you are going to see in Hadoop. Okay, that execution model and Spark execution model are different. So here Hadoop is taking 3.4 minutes, where these have taken days of time. These have taken, see, I'll come back, right? So these have taken days of time. These have taken hours of time. These have taken minutes of time. These have taken minutes of time. But it has taken minutes, but Hadoop compared with Spark, Spark is 100 times faster. Then what will be the speed of Spark? You can see, right? Seconds. In the case of these databases, right, you got some, if you see the current databases, limited storage. In most of the databases, no parallel processing. And most of the databases handling structured data. They cannot handle unstructured or semi-structured kind of data. But here, this Spark process all varieties of data. Okay. So this is what the speed this is given, right? Spark is because of this in-memory computation, distributed computing, and parallel processing, right? Spark is got very high speed. That's why Spark is the for especially for big data, for huge data, right? Sorry. Spark is a very high speed execution engine for processing huge data. So in total in Azure data engineering, total data engineering, we talk Azure Data Factory, Azure Databricks, in Azure Synapse Analytics. Mm. Azure Synapse Analytics, right? The main Spark is the main execution engine. In ADF also, everything you won't write any Spark code. You will be just performing some kind of drag and drop operations. Internally, the ADF, internally, all this, they'll be converted. Here in ADF, we create data flows. We create data flows. Data flows should be converted internally. When you execute the job, they'll be converted into Databricks jobs. Internally, they'll be converted into Databricks job and executed by Spark. If you see in Azure Data Factory also, people who has knowledge on this Data Factory, there also until data flow debug, if you on, you cannot work. Data flow debug, if you are running, means Spark cluster is going to start. If the Spark cluster starts only, execution happens. So here total executions happen in total Azure Data Engineering, Azure Data Factory, Databricks, and Spark. Spark, without Spark, the processing cannot happen. Okay. So here, why PySpark? So see, Spark can be implemented in multiple languages. Spark can be implemented in multiple languages. Multi-language support using Python, using Java, using Scala, using or language. Yes. Here in our course, right, PySpark means Spark with Python implementation. What is PySpark? It is a Python API. PySpark is the Python API to use a Spark. PySpark is the lightning fast technology that is designed for fast computation. It is one of the demanding tool among data engineers to work with bigger data sets. So today, if you see huge data getting generated everywhere, the huge data has got hidden patterns, unknown corrections, market trends, customer preferences, right? And other useful in business informations. So we need to extract valuable informations from that. So we need to have some efficient tool to perform that type of operations. So previously, I don't say that it doesn't have any tools previously. We have got many tools previously available, but that they're not that much so appealing. It's where today industry is expecting quick results. We need some scalable and flexible tools to crack this big data and gain benefit from that. So PySpark is such a kind. So combination of Python and Spark is the more efficient for the world of big data. That's why Apache Spark community came up with a tool called PySpark, Python API for using Spark. You may ask why Python? PySpark. Previously, in 2014, 15, 16, 17, 18, Spark with Scala is preferred. Spark with Scala language. But today, Spark with Python, what we call like PySpark. Because Python has got many modules, especially towards ML, machine learning. So Spark MLlib library. We got Spark MLlib library also available. Even for machine learning kinds of things, that Spark has got special library like machine learning library. Okay. For that, Python has got many modules available. Python is providing many. Even PySpark is a Python library. Even PySpark is a Python library. Import PySpark, we say, right? Python library to use Spark. Okay, fine. Hope you got some idea what is Databricks, what
Sir,
is
I have
Azure
one
Databricks.
question
Yes, go ahead.
uh, regarding the cluster. So,
Mm,
as you mentioned that cluster is nothing but a combined group of nodes, like a system.
mm. Yes,
Okay.
yes.
So, is there any condition that all the nodes, like all the systems, should have the same capacity, like CPU, RAM, storage, or it can differ node to node?
All should have the same. Means not like that. See, generally here in the case of on-premises, okay, it's possible. In
Mm-hmm.
case of on-premises, right? You can see today I'm connecting. I got some 10 systems. I have
Correct.
interconnected. I created a cluster. Tomorrow
Mm-hmm.
you purchase some 20 more systems and you want to see commissioning and decommissioning. We say adding and removing systems. Commissioning, you are adding 20 new systems with new configurations. The old systems with old configuration, new systems, totally 30 you got. Again, after 3 months, again you brought some new systems with new configurations. 50 you got. Means the systems will be having different configuration. They will be running okay. But here, the cloud side, whenever you are creating cluster, whenever
Mm-hmm.
you are creating cluster, it will ask you
Mm-hmm.
want a single node or multi-node. Single
Mm-hmm.
node means that is single node that only acts as a driver, that only acts as the worker.
Correct.
Multi-node, if you say multi-node, it will ask in multi-node what it is going to ask. Okay. For multi-node only this option you will get. Single node you won't get. What is the driver configuration you want?
Mm-hmm.
What is the driver? That memory or that CPU, that everything.
So everything
Driver.
will be applied same, right? So all the
So
nodes.
driver configuration to ask. Similarly,
Mm-hmm.
driver configuration you can give some more. Similarly, worker configurations. Worker configuration to ask. What is the worker
Mm-hmm.
configuration? The RAM capacity, that everything, that whatever the system specifications, everything you can provide. You can select it, the best configuration, everything. And afterwards, what it will ask? Number of workers. It will ask how many workers you want. Min it
Mm-hmm.
will ask. Max it will ask. Min how
Mm-hmm.
many? For example, if your practice purpose, if you're 3, max how many? 10. So in this way, it will ask for all these workers, whatever configuration you're giving, that will be taken, that will be considered. For
Okay.
driver, whatever configuration you provide, that it
Okay.
will take.
And same
If
configuration will be applied to all the nodes, right?
yes, the worker configuration will be for each. If you're taking 50 workers, for 50 workers, we cannot provide that. So here, as it is cloud, everything is invisible, everything. So this is very simple in the cloud side, but in on-premises side, it will be lot of time taking if creating clusters, right? It's
Mm-hmm.
very big task. Previously, everything was on-premise, right? So it was a big task. You need to install that different softwares to be installed,
Mm-hmm.
and you need to for each every system and interconnected all those things, right? But here, you don't do anything. Just everything within 2 5 minutes. Hardly it takes 4 to 5 minutes for creating. Just you will give the configuration. Create option will be there. If you create it, the cluster gets around 3 to 4 minutes. It takes for creating the cluster. That's it.
Okay.
You're not going to do any installations, anything about again Spark installation, all this. In on-premises, you need to install Java on top of Java, Hadoop on that Spark, everything again, all
Mm-hmm.
that lot of
It's
installations to
hectic
be
work.
done.
Yeah, yeah.
Settings
Got
will be there, but here everything, yeah, it takes care.
automatic.
You no need to do anything, right? Everything available. Okay.
And the second
Yeah.
question, sir, with respect to multi-node,
Mm.
so who will going to decide our there is any configuration for like a worker node or master node, something like that, or I mean, is it configurable, or how it will going to decide who is the master and who is the worker node, like driver node?
See, driver node configuration will provide separately. Worker node
Achha.
configuration will provide separately, and all the workers will take this configuration, whatever you are providing.
Okay. Mm-hmm.
Compulsory when you go for multi-node, you'll ask driver and worker. What
Mm-hmm.
configuration for driver, what configuration worker, and how many workers. For single node, it won't ask. Only the node, one node configuration. It won't driver, worker, it won't ask. Only the node configuration it will ask.
Okay. Okay. Got it. Sure. Thank
So
you.
this all we'll be discussing, everything we'll be discussing practically. You people will be doing parallelly along with me. This Databricks sessions will be it will be better if you are doing along with me parallelly, hands-on. Means if anywhere immediately, if you got any error, you can share the screen. This clusters creations, a lot of other configuration settings, lot of what we say credentials will be creating directly. If you want, if see Databricks is there, Azure Databricks, ADB is there. ADB wants to get data from ADLS. Databricks wants to take the input from this data lake storage. It wants to read data, and Databricks wants to write data into ADLS. Directly, it cannot. You need to mount it. How the mounting process is going to happen? How to integrate this Databricks and ADLS so that the Databricks can take data from this and write data into this. And not only for that, for Azure SQL also. For Azure SQL also, how we can what are the things required, how you can mount. And here mainly thing in the case of Databricks, if you go for interview aspects, so mainly they'll ask a lot of questions in Unity catalog. What is Unity catalog and how you are implementing the Unity catalog? What is the first level component? What is the second level component, right? So one second, lot of one second. If you see this, right, clear notes, don't worry about the notes, everything will be clear here. All topic wise, the notes will be available. So how to calculate the cluster memory in Spark, creating and scheduling job, working with notebooks, how to create ADB instance, types of schedulers, and notebook menus, magic commands, how to work with magic commands, Databricks utilities, widget utility, Databricks file system, what are the other file systems, mounting process, data lake with Databricks file system, problems with mounting, and the Unity catalog. See the diagram for this Unity catalog. This is the main thing. Lot of interview questions from this Unity catalog. Everything step by step in brief we'll be discussing. See the first level component, second level component, third level components. Just I have drawn in the paint. So here in the if you go Unity catalog, you'll add users, you'll give privileges to the users, and here dev catalog, QA catalog, prod this is you'll be creating this catalogs. First level is the catalog, and in that again in dev catalog again you will create databases. In our Databricks terminology, databases means schema we say. Create database name. Let's similarly create schema name. Within the databases, again tables you create or views or functions or volumes. Again tables managed, unmanaged, volumes managed, unmanaged. And here we'll be creating locations, external locations, storage credentials. So many credentials directly your Databricks cannot interact, take data from data lake. People who has got knowledge on it's ADF, data factory, you create linked service this there. Here, not that linked service. Here you have got a lot of mounting process will take. So we'll have physical layer, logical layers will be there. So just I was briefing you. So Databricks Unity Catalog, Lakehouse platforms, setting up Unity Catalog, provisioning, adding users, adding user groups, creating metastore objects, granting privileges, Delta Lake, data frames creations from JSON files, loading data from CSV, creating data frames, PySpark functions like delta tables, different ways of reading, different ways of inserting, different ways of updating, SED type 1, audit log tables, ADLS Databricks storage. So many things. So in brief, topic wise, you can see more like 80 to 90 documents you'll be getting as part of this notes. So you can once again check with this course content. Yes. And for each and everything, video is available. Every session is video recorded. If you are absent to any session, you'll be getting the recorded video and clear soft copy of the notes. For every batch, the notes will be created and hands-on sessions can do parallelly. If you get any error, you can share the screens. And today after the session you practiced, you got some error. No need to wait until the next session. A WhatsApp group will be there for our discussions. For all my batches, a WhatsApp group will be created where you can take the snap of that error and you can post in the WhatsApp group. Anybody can answer. I'll be answering. Otherwise, in the next class, the start of the session, you can share the screen immediately. The where that error occurs. You need to know where the errors are occurring also. And also, like interview questions, this Azure Databricks. So if you see this Databricks, this data engineering in this Databricks PySpark has got a great boom today. You can check in this Google, right? The jobs like even if you have got good command on this Databricks with combination of PySpark, especially, right? If you have got good command, you can demand for the salaries, even like 2 times uh, double the salaries you can demand for it. Similarly, the industry is expecting the people with good command on this Databricks and PySpark. So by this, if you see the course content in brief about, if you compare with other training sites, just they may be discussing about this, but they'll just provide you in data in Azure Databricks. They will be providing overview on this PySpark. But in this course, we'll be discussing in brief about this total PySpark, Databricks with PySpark. In that, I'll just provide you some knowledge on this big data Hadoop and Spark before I go with this actual Azure Databricks, creating cluster management, plus Databricks utilities integrations. And here, if you see PySpark, especially SQL data frames creations with many functions providing for working different types of operations. We don't need to write huge codings here. We are not going to write any customized code. We'll be writing wherever required, but many functions given API functions are there, data frame API functions. Previously, we used to have RTDs, RTD, resilient distributed data sets, but it doesn't have schema. Now it got outdated. Mostly we are going with data frames and how to work with different file formats with the batch processing, historical loads, incremental loads, external sources, streaming API, workflows in Databricks. Right? Okay. So tomorrow we'll continue more discussion, right, on this Databricks.
So one
we
more
have
question.
Yes.
migration.
Okay, go ahead, please.
Yeah.
Yes.
Do we have the migration in the course details, like from one DB to Databricks migration?
Databricks, yes, I'll be discussing.
Okay. So from one DB, like let's say net is our Synapse, not Synapse, sorry, Snowflake, something from there to Databricks, something.
Yes, yes, I showed you the course content, right? And how you can connect. 1 second.
I don't find this listed.
Databricks integration with Blob, data lakes, databases, Synapse, Snowflake.
Oh,
Databricks
integration.
integration with this all this SQL
I'm checking
database
for the
Synapse.
migration from one warehouse, database warehouse to the Databricks.
See, Databricks has got, see, generally, whenever you create some Databricks instance, you will be getting, if you're working with Azure Databricks, whenever you're creating Azure Databricks instance, you will be getting by default as data lake. You'll be getting a default data lake you'll be getting, but default data lake we won't be using it because we doesn't have, as you have not created automatically it got generated. So what we will do initially, we will create our own data lake file system, which acts like a, mostly like it acts as a staging area in your projects. So we will create and we will perform all those things. See, generally in Databricks, right, it will be uh, the default, the storage systems, whatever, we won't be using. We will be creating, otherwise we'll be using other, you will integrate with other things. If you see in Databricks, 1 second, I'll make it clear. Here, if you talk about Lakehouse platform, this is the main thing. This is the diagram I've drawn in the paint. See, users will be there at the top level. Databricks workspace will be there. You will create Databricks workspace. In the Databricks workspace, multiple users can communicate together. They can work parallelly together, right? That is the importance Databricks workspace. Within the, once you create Databricks workspace, you will create a cluster, Databricks cluster. Once you create cluster, multiple Spark applications will be running. Spark applications, right? That on this cluster. And Databricks Spark applications to read or to write data. See, Spark is for processing. It is not going to store anything, right? So here, Unity Catalog data governance will be there. Means physical layer, this is your physical layer where your data lake, where your containers, your data, everything you are going, your data sit in this physical layer, means which is that data lake or whatever you take, right? So physical layer is what your data storage layer, and logical layer means whatever you create the databases, instances, other things. So if Spark applications here in Databricks, Spark applications wants to communicate with the storage systems, it has to come across the Unity catalog, data governance, lot of things, the credentials, everything, external locations, everything will be seeing. So here Spark applications, if you want to read from this, if you want to write into it, right? So they should come across the Unity catalog. So majorly, Databricks is providing a cluster, Spark cluster. Spark cluster for is providing cluster that on that cluster only the Spark applications are going to run. So here, if you see, this is done by total data engineering team. Data sources like systems, databases, websites, file servers, mobile apps, IoT devices. From there, you are going to pull the data. You are going to pull the data. You are going to pull the data means what are the data ingestions, like Azure Data Factory is there, Kafka is there, data ingestions data. Where the data is going to come into data lake. Data comes into data lake. From the data lake only, your Spark applications, it's Databricks cluster, the Spark application, it wants to read, it reads it. Again, if you want to write, again, it will take that storage systems. So that's what Databricks, normal Databricks, it is not compatible with all the Azure storages. But Azure Databricks compatible with all the Azure storage service. So this storage, you data ingestion happens, it will be stored in the Azure storages. So that is what Databricks can integrate with any kind of storage. Like the ADLS, generally in Azure related means Azure Data Lake, Azure SQL, Azure Cosmos DB, Azure Synapse. It can be even it can be a Snowflake. You can integrate. Okay.
No.
These things I'll discuss in brief later in part of our course. You can do a lot of integration. Spark can be integrated with different things. Spark can be integrated with Big Data Hadoop. Spark can be integrated. We got HD Insights available for Hadoop in cloud side with Apache Hive or with any of this. Yes, Narendra, okay. Just go with your query. Yes.
Yeah, just we need that ADF is completed, right? Can we get interview questions?
Yes, yes, I'll forward.
Yeah, thank you, sir.
Sir, I do have one question.
Yeah, on the cloud side, so we are going to focus more on the Azure part.
So here in our course, Databricks with Azure, right? Azure Cloud.
So actually, in my
Databricks.
company, they are using the GCP.
So for GCP also, I'm handling for GCP. GCP data engineering batches also but they are in the weekends. GCP data engineering batches I'm taking in the weekends, Saturdays and Sundays. You can check with the front office, right? The demo will be there, the weekends.
Okay.
There also will be discussing data engineering, GCP data engineering.
Actually, I'm already part of your GCP batch, which is 6 p.m. right?
So yes, sir.
In that, I think PySpark step also we are going to cover.
In that I'll be discussing, yes, Databricks is there, Dataproc is there, that will be discussed. Still not covered.
Okay.
Okay. Yes, Mahendra Patel, right?
Yes, sir. So just wanted to know, ask you about like, I mean, I'm really new to the PySpark world. So is it mandatory to know the measure of the concept from the PySpark? Because I seen that it's a completely database. So are you going to cover all the concepts from PySpark or just few concepts from
See,
PySpark?
one thing in the industry, knowing Azure Databricks, but if you have got a full command on this PySpark Databricks with PySpark full command, right, it has got a great demand today. So that's why in this course, majorly I'll be discussing. See, you can see in the course content I specified, right? As compared with other training sites, they'll just give overview of the PySpark, right? But here we'll be discussing in brief. So these are all Databricks. If you see PySpark also in brief, it is covered. PySpark, can you see here? PySpark data frames, APIs, PySpark SQL functions,
Major of the
PySpark
concept
build.
will going to clear, right? PySpark concepts.
So everything you'll be getting clear idea about it.
Okay.
Sir, any
Sure.
prerequisites to learn this course or
Prerequisites is nothing but some basic Python knowledge, right? Yeah, basic Python knowledge. That too, I'll just take some 2, 3 sessions where you can cover all the Python syntaxes. Python is not a complex programming language. All the statements looks like normal English statements. So I'll just cover the syntaxes. Otherwise, the videos will be provided from the DurgaSoft side. You can go through meanwhile. Okay, fine.
Sir, when the batch will going to start this? I mean, this
This
database.
is this first session, tomorrow second session, day after tomorrow third session. It keeps going.
Okay.
These things won't be repeated.
Okay.
Tomorrow also people can attend. Can tomorrow and day after tomorrow. But initially I'll discuss about us. Okay, next I'll be discussing how exactly the processing is going to happen. Fine.
So
Any
the
other
classes
queries?
will be every day, right, sir? Or we can on.
It's every day, same timing, 10 to 11. 10 to 11 it will be. Okay. Any other queries you got, anyone? All the sessions will be interactive sessions. At any point you can ask during the session when we enter into this. There's nothing theoretical, everything practical, right? Even when we go with the practicals, people can do the things along with me parallelly. Especially for Databricks, Azure Databricks, I recommend you to do instead of watching the sessions, doing the things parallelly will be getting more idea about what you are performing. Okay, fine.
Do we have a timing little earlier, like 9 a.m. IST?
No, 10 a.m. As of now, it's 10.
Okay, 10 a.m. every day, like weekend as well.
10 Monday to Friday it will be.
Okay, so it's 45 days from today.
So Monday to Friday, sometimes I'll be taking, so not all the Saturdays. So it will take 1.5 month.
Okay.
Fine. Okay. So if I'm done with the
Can we
queries,
have your number, sir?
actually I should not provide, but okay, this is mine.
Give me a second. Thank
Okay, fine. So if I'm done with
you.
any
Do we
other
have a
queries,
link for the today's session?
what is it?
No link. I mean, do you have any YouTube link for today's session, or will
You'll
it
be
be
getting
shared over
through,
the email?
you'll be getting through mail, right? With whatever mail
Oh,
you have shared. Otherwise, in the tomorrow session, tomorrow at the start of the session, they'll forward that link in the Zoom chat for in the tomorrow. And today,
okay. Tomorrow.
after the class, after 1 hour, 2 hours set, after 2 hours, you will get a mail, that link of that YouTube link, today's class.
Okay. So tomorrow we need to use the same link to join.
Same link you
To
can, yes.
Yeah.
Same link, same time at 10 o'clock to see more discussion, right? Yes. So thank you all for your time. Thank you. Meet you tomorrow. Bye.
Thank you. Sure. Bye.
Yeah. Thanks. Have a good day.